Hi, everybody. I'm Spyros. This is a session on how to build a mostly mature security budget with very little money, budget for pizza. Apparently, it's what most people are trying to do these days, that nobody has any money for real security stuff. First, before I start, can I just say, this is a great event. I've really enjoyed everything about it so far as a speaker and as an attendee. And let's start with some basic things. Hands up, who here is working in security? Wow. We need to talk. We kind of need to talk. But OK, so the audience is, I guess, mostly developers. This is great. I'm going to spare you high-level security stuff and just do mostly other things. So how many of you consider yourselves technical? Great. I can talk about code. And how many of you specialize on something extremely niche, like, I don't know, IoT versus being a generalist? OK, mostly generalists. This is amazing. So, as I said, my name is Spyros Gasteratos. I work as a security engineer / architect, and I have a very small company where we essentially help companies with developers set up secure development lifecycles, DevSecOps, whatever the marketing term is this week. And in my free and non-free time, I am an open source developer. I maintain OpenCR.org, Draon, and many other projects. You can find me on GitHub as an email, or if you are not scared of scanning the QR code of a security guy, you can do that at your own risk. So, but this has nothing to do with me. This is a case study. And this case study is essentially an overview and a celebration of our global open source community, what we all have collectively achieved and we keep maintaining day to day for free for everybody. And how you can use it. In other words, pretty much how you can leverage the collective work of the security hive mind, new term, to achieve the equivalent of a very large team without losing your sanity in the process, which is what usually happens when people do it. It's not all roses and unicorns, otherwise everybody would be doing it and I wouldn't be here talking to you about it. It's a process with gotchas and we will cover them. So, everybody, case study begin. Meet Jane. Hi, Jane. Jane, let's say, is an experienced security professional who just got hired in a regulated, medium-sized company who's cloud native. And to keep things interesting, so I can present as many things as possible, let's say this company has no internal security function. Pretty much, so Zap, day 0, what do I do? In every story, as in this case study, every story needs a hero and a hero needs a mission. Jane's mission is to build a secure SDLC / DevSecOps program with a focus on product security. As usually, budget, what budget? You start from 0, and when you convince your colleagues and your boss that they need to put their hands in their pockets and then take them out with money, then you unlock budget. Essentially, you need to convince that what you're going to do is going to provide some value. Industry standard so far. So what does our hero do? Our hero starts reading white papers, reading reports from all the big companies, all the big consultancies. They watch conference talks like hopefully this one in the future. And they try to piece together a plan for the next month, 6 months, or the next few years. Keep in mind, this is everybody's marketing material, what they just read. So any guess what happens next? OK, I'll give it away. Security marketing is a little bit dodgy, so fear. Pretty much capital letters, marquee on an H1. Have you been hacked already? Hire us so that you know if you have. Uncertainty. Is your data in the dark web? Pay us to find out. Doubt. are you doing a good enough job? Give us unlimited money to find out. Obviously, this is not productive at all. And why is it not productive? Well, because there is so many things to do. Security is a very multidisciplinary approach. You cannot do just one thing. You cannot just buy one thing or use one program. Otherwise, we wouldn't be here and we wouldn't be talking about it. And there is not enough time to do everything by one person. Why? Security is multidisciplinary, as I said. But as you all know very well, you cannot multitask. Multitasking is not efficient or effective. So where do we start? Well, we start simple. We map the steps of our SDLC on a very crudely drawn diagram, as you see here. And for every step, we can choose the actions we can take. And we can assign weights to those actions and prioritize. This is simple, right? You can do this, and thank you, you can do this, and this is the result. Thank you for coming to my TED Talk. That is what I would have said if it was actually simple. As you see, just by drawing circles and figuring out what controls need to be done or what actions need to be taken, I've created a monster or an abomination. This is still too many things. And also expensive. If Jane goes and hires or buys something for every single one of these smudges, that I will explain in a second what they are going to be spending more money than the company is getting from selling their products. Not effective, unless you're a government. So let's fix this. Every single handy person or handyman or maker in the world starts by assembling their toolchain. So let's assemble our toolchain. Our toolchain can start with freely available resources that, as I said, the global open source community maintains. Over at OWASP, OWASP is a global NGO stands for Open Worldwide Application Security Project, and it's a global NGO for, well, you guessed it, application security, and it's open source, and they have made, well, I have made, among others, the application security Wayfinder. It's literally draw.io diagram, which maps your SDLC, and for every step, it maps specific free resources you can use to secure it. Why, though? Usually, what people say is shift security left, so why not just dump all the security requirements? Well, shift security left is a marketing term, and as such, it is absolutely useless. You don't shift security left, because if you shift security left, you will only look at one part, and then people can make mistakes in every other part, and then you are left hanging again. So what do? We shift security everywhere. Security is quality, and you wouldn't just put quality on one part of your code or one part of your process. You will put quality everywhere, similar to security. So now we have our map, index, dictionary, something of our free tools. Cool. How do we prioritize? Because priorities. Well, OWASP has the software assurance maturity model. It's an extremely popular, worldwide used by both governments and companies maturity model, very well tested, and it helps organizations implement a strategy for software security. In simple terms, it tells you what you need to do. It's a great start. It even has a questionnaire, which as developers you can fill, and it gives you priorities for what you need to take care of. For example, I filled the questionnaire for an imaginary company, and it gave me this nice diagram, which I can tell my boss how to do things. For example, here it tells you out of 3 that policy and compliance were very high, but we have no environment management. Great. Now we have intentions, right? What needs to happen? We should add controls. How are we going to make this thing happen? And for developers in the room, which is most of you, These are the intentions. For example, intentions like verify that all unneeded features, documentation, sub-applications, and configurations are removed before you get to production. Checklists. If this sounds like a checklist, it's because it is a checklist. We will use another open source framework called Application Security Verification Standard to do so. ASVS is used by several European governments, maybe the US as well, but I don't know, and literally every company out there, including the big ones. And with that, we have a plan. We know what we need to do and how to do it. So the plan, we use some to create high-level priorities. We use ASVS to learn how to implement. We use the Wayfinder that I showed earlier to discover projects that can help implementation on every single stage. And then what? Well, then we finesse some things, apply our magic sauce, and we gain some profit, hopefully. For example, what about training? For developers in the room, security training, you can do it for free if you want to learn anything about security. There is lots and lots of vulnerable web applications out there. My favorite one is JUSOP. It's developed by a gentleman named Björn Kimmich from Hamburg. And it's great, more than 100 challenges, deploying Heroku with one click, stuff like that. What about secure design, another SDLC step? Well, secure design for me means threat modeling. Threat modeling is the exercise of answering 3 questions about any application. What did we build? What can go wrong with it? And what are we going to do about it? If that sounds like Monty Python, it is because that's where they got the question format from. Threat modeling has several projects. Cornucopia is on the top right. It's literally a deck of cards. If you need an excuse to play cards in the office, that's your excuse. And you can, they describe things that can go wrong with your application, and you can use it for threat modeling. Once you get a little bit more advanced in threat modeling, you can maybe draw diagrams or even do continuous threat modeling as code with something called PyTM down here. All of these great resources. But on top of that, another SDLC step, validating secure architecture and implementation. This is what most people focus on these days, and this is why we have so much noise when we scan something with security, because we've never done any secure architecture. And this is where our industry really shines, right? There is a ton of documentation and projects you can use. It really, I can do a whole talk on this or several days workshops. But for example, there is a group called Cyclone DX that focuses on third-party risk, how your libraries are secured. If you search GitHub for static code analysis for your language of choice, you will find a lot of things. Dust, so dynamic analysis, there is something called ZAP down here, etc., etc. Literally many more. And for developers, again, there is cheat sheets, which is by far, in my opinion, the best guide out there. One pager, including code, how to do something secure in any language or framework. Now that we have results and we have scanned everything and we have designed everything correct, we need to do vulnerability management. We need to track what happens after we found something. We can do this with many professional and free resources. One of them is Defect Dojo. Defect Dojo is a Django application that handles vulnerabilities, imports from any tool, etc., etc. Most important thing, it gives you insights and it gives you graphs so you can show your boss and get more funding. Operations, of course, security needs to be embedded everywhere. You cannot just put security and stop it at development. Things get attacked all the time. So this is another example where you can find unlimited resources, not only from OWASP, but for example, the Linux Foundation has CNCF, and CNCF has a ton of projects. OPA, Open Policy Agent, allows you to do policies as code into any environment. Cilium allows you to do eBPF and observability. Istio, great service. Service mesh allows you to encrypt traffic and allow traffic within any cluster. SPIFFE Spire, identity and access management, and literally, again, I can do several days worth of workshop only on this. So we've implemented all of that now. Success, right? Everything is working. Jane has even unlocked budget for 5 people. Everything is roses. We are doing everything we need to be doing, right? Well, not really. If we go and use all the tools and implement all the things, what is going to happen is that we're going to spend a lot of time maintaining them, because everything you do has a maintenance cost. And our vulnerability backlog is going to grow continuously. And every audit we do, remember, we are audited. We do security for many reasons. One of them is so that we can keep operating. And audits will usually take weeks or months to prepare for, and engineering feedback will be poor. Essentially, every single developer will hate us with a passion because we get them to do extra work. Also, we get them to do extra work because all our scanning and pen testing has a ton of false positives. So we tell people to take care of stuff that is not true. And lying to people, not a good thing. Why? Why are we doing all of this? Well, if we implement all of this, we end up in operational hell, right? But why? If we followed every white paper, right? We integrated everything perfectly. We even watched all the conference talks. Well, everything we implement, as you very well know, has an operational overhead. For example, every tool needs maintenance. You cannot run a linter and forget about it. You cannot run a security tool and forget about it. Every vulnerability, every alert needs some sort of human interaction, right? Monitoring, logging, and triaging. If you have the same team doing all of this, even if you have developers doing all of this, you are not going to have a nice time because security tools are very noisy. And when we move to operations, this becomes exponentially worse. For example, if we use a web application firewall, we're going to have even more noise. And of course, every time we get audited, we need to relink and figure out what the auditor wants us to do, or the auditors want to ask us, how does this relate to what we are already doing? This is a lot of work. So how do we reduce operational overhead? Well, it's relatively simple. We can automate, and automate. And this is what people say, and this is a nice excuse. Better, we can use the community's automation. This is a community talk, so obviously we're not gonna write any code ourselves. We wanna be lazy. So let's start automation. Simplest automation, how do I talk to other people? A lot of security things are communication problems. For example, I've already listed a few projects and a few frameworks. Probably you have no idea what I'm talking about or what these frameworks even mean. So how do I explain to somebody who cares about code or cheat sheets what means some maturity level X, or how someone from the US who only cares about their National Information Security Standard, NSA, how does this map to what we do? Furthermore, how do I explain to developers what ASVS requirements, what checklists they need to fill and they need to have? Same for QA testers, right? How do we test a specific application for specific vulnerabilities? Well, there is a project called OpenCR, Open Common Requirement Enumeration, and this is a universal translator for security information. It also allows you to ask questions with a chatbot powered by, well, ChatGPT. You know how it goes. We made this a while ago with a global cohort of security people, both in governments and not. And I'm going to give you a demo right now. I just hope the video plays. Can you see that in the back? OK, good. So let's pause real quick. Say that you want to find out, say that Jane, your security person, asks you to find out that what we do about verifying that consumers of cryptographic services protect key material and other secrets using key vaults or API alternatives. Essentially, how do we handle our keys, encryption keys in production? Well, you can go to OpenCR and type that in search, and then it will give you the relevant ASVS, which if you follow, it gives you the common requirement, which if you click, it gives you everything else the platform knows about, so you can disseminate information easily, freely, and give the relevant people relevant information. For example, if you're a developer, here's a bunch of cheat sheets on how to do crypto. If you are a CTO, here's a bunch of NIST. If you want to do, and if you are audited by ISO, here's ISO. And if you are a developer, here's JUSOP at the bottom, which can help you do that. However, that is boring and very dry. Why not ask some bot some question and get it to do what we need it to do? So we made OpenCR chat, powered by several known AI agents. And you can even ask it simple things like, how can I store key material securely? Very common problem if you handle payments. Here, payments companies are very popular in this country. And it will tell you exactly, but also it will not hallucinate, because it goes first in our database, finds out exactly what curated standards exist, and then just tries to explain it. If you want more information, it has context, and then you can even say, give me a cheat sheet, and it will give you the specific standard you need to follow. And here's the link. You haven't seen any other agents give you links to original resources, right? Similar for gap analysis or map analysis. If you're doing one thing and you want to find out how to do another thing, and we know about both things, you can just click real time, and it does gap analysis. Behind the scenes, to be a little bit more technical, it's a graph database, Neo4j, and it just does smart graph math. So you can do all of this, and using OpenCR, you can find information on. Awesome. And using OpenCR, you can find information on any standard. It is pretty much a universal translator. If you watch Star Trek, that's where we got it from. And you can use it to communicate with stakeholders, translate between security speak, developer speak, or CTO speak and developer speak. We use it to simplify audits and link information. There is a bunch of advanced use cases which are out of scope for this, but we can talk. And now Jane knows exactly how to communicate, how to audit, and how to gather requirements, and how to train people, because CRE has training. Free and open source, by the way, right? And open data, right? So we solved security forever. Thank you for coming to my TED Talk. And this is exactly what I would say if that was the case. We have made some progress, but we're not done yet. We have a little bit more things to do and a little bit of ways to go. Because so far, we have communication, but time spent on vulnerabilities is still going to be very high. We haven't, remember, our tools are very, very noisy. We cannot just leave them running. They are going to become gremlins, and they're going to drown us. So what in our use case, what Jane's first reaction was to think that their team is slacking. And first question is usually, okay, who do I fire? Who from my team is not pulling their weight? Well, in reality, the team is running around like headless chickens and in a panic because they cannot handle the noise. Second reaction is we need automation. Third reaction is, but we have automation. We've automated everything. So what do? Well, we need automation that runs our automation. Meta. So let's create automation for our automation. We need something that orchestrates a bunch of tools, that can tag duplicates, that can present results in developer-oriented dashboards. I have never met a single developer who likes to log in to 5 different tools just to make a build. Is there someone like this here? Awesome. Okay, cool. Still haven't met any person. So we want to be able to visualize things in different places, and we want to be able to add missing information to any tool, because no tool, security tool in the history of making security tools has access to all your information. For example, no scanner will ever tell you who needs to fix the damn bug. No scanner will ever tell you how to fix the damn bug with context from your code, even the expensive ones. And we want something that is plug and play, and we want something that is extensible, because as our code grows, so do our security requirements. If we have a requirement now, does not mean that we're going to have the same requirement a year down the line. And as I said, we are lazy. We do not want to be changing stuff all the time. Well, in OWASP and other places, we made Draon a while ago. Draon is automation for automation. And it automates tool execution, automates enrichment of findings, and in short, gets you from place A to place B, where you treat all your tools as an all-in-one. That's about it. You can find it on GitHub under Ocurity under Draon. And I'm going to give you a very short demo because we are running out of time. Draon is command line. I have 0 React skill. And you will see if I ever make a website. But essentially, Draon is containers on Kubernetes. It's a CI/CD system, but for security. And you can do 2 things, as you can with every CI/CD system, either install a CI/CD pipeline or run a CI/CD pipeline. That's it. I've installed and started one. As you see, here's all my previous ones. And this is going to run a bunch of tools that either auto-detects or you tell it what you need to do. And it's going to run it on code or infrastructure, as I said, open source. And it takes as long to run as the tools themselves. Think of it as GitHub Actions, but with a twist. And we can, I guess, forward a bit. Maybe not. I thought we would have problems with live demo, not recorded ones. There we go. Everything is running. So we can forward. And as you see, as things succeed, yes, it's still running. Okay. So as things succeed, you have an overview using existing Kubernetes tools, which is the most important because we do not want to have to look at yet another dashboard. As we said, we're all developers. We want integration. And once this finishes, which is happening around here usually, once this finishes, you have a layer of security tool automation, a level of enrichment. In this case, we've done the duplication and policy enrichment. The duplication, because if you didn't fix the damn finding yesterday, you're not going to have to fix. You're not gonna fix it today. Means it's a duplicate or a false positive. It doesn't matter. And once all of this finishes, which I'm gonna forward a bit more. You're going to be able to run a layer of consumers, which is exactly the integration layer of your security tools with the rest of your stack. In this case, we assume that everyone uses Slack, Jira, and Elasticsearch, which a lot of people use. And this finishes eventually. Jira, because that's what a lot of developers we asked and are in our community like. And this is usually the output. You can customize everything, and it allows you to have less tickets. Most tools would create tickets. Slack, because most people do not like to be bombarded in Slack. We just serve a short annotation or a short alert. And once this finishes, cool. And then Elasticsearch, because who doesn't like colors and nice graphs? And this is what Jane uses to talk to their boss, because everyone likes nice dashboards. This gives you a single pane of glass overview on your security stuff by everybody. It's completely open source. And details, I guess you probably don't care about that much, but it allows several people to see different views with one pipeline. That means no extra work needed to integrate security into development, into the rest that you are doing. I am going to move forward. And with that, Jane can use Draon as a universal orchestrator. Think like Kubernetes, but for security tools. And this way, we can automate security tooling execution, results enrichment, and put results into the visualization and appropriate dashboards based on who needs to see what. Awesome. So we solved security forever for the third time, right? Well, kind of. With that, we have automation, communication, and a plan. So that means that we can execute this plan and save time. To recap, and I'm going to leave you with a few things, please use free resources. Remember, there is a limit on what free resources can do. If you don't automate as much as you can and use automation for this automation, you're going to have a very bad time. Trust me, I know. After a point, and this is because after a point, you will trade team time for free tools, which are great, maintained by some very smart people, but they're not meant to save you. They're meant to save you some time, not all the time. There is a need for documentation and automation unification. This is where the projects I just demoed come in, and please use them. There is automation for your automation. And most of these resources accept sponsorships. Please pay your open source developers. We don't need it very happily, but most of the other projects do. And if you can, donate. Awesome. And if you are left with one thing from this presentation, it is this. Security has to only be as hard or complicated as we want it to be. There are many steps that you can take to make security easier for everybody without dropping the ball or without willfully ignoring things. Thank you. Any questions?
Thank you very much, Spyros, for your insightful presentation. Do we have any questions?
Awesome. Means I was perfectly clear. Or nobody understood anything.
While no one has any questions, I do. The speaker previously, we were talking about hacking. He said that hacks happen because developers or human makes mistakes. So I have a question for you. What is the most common mistake in the security field? It can be even like a very superficial or very dumb mistake people tend to make.
Security is multidisciplinary, as I said. So it really depends on what you look at. If we look at the human element, phishing, don't click links on emails, don't visit random websites. It can be too much work and very little bandwidth to, for example, update libraries and update browsers and update components, which you should be doing. Or it can be wrong tools, where your tools do not detect the right thing. Humans make mistakes indeed, and they will always do, but we should not blame humans and try to fix humans. We should fix the automation so that it helps humans to make less mistakes or make things secure by default.